Good morning, everyone, and thank you to SK for putting this together and to Tiffany for handling logistics and slides. I am a digital fabrication lab specialist at USC Iovine and Young Academy. We have a really wonderful makerspace that just opened up this year, and I have been in conversation with folks from Keck and from Viterbi for what feels like ages now, but what has really been about 2 weeks, less than 2 weeks. Originally, my coworker Jacob Padapoff and I were looking at making the Prusa design-based reusable face shields, but even with our complement of 10 FDM printers, it was apparent that our output would be very limited. So right away, I was looking for options that would be more reliant on just our laser cutters. We have 3 fairly large laser cutters. I found a design from the University of Wisconsin's makerspace that they shared. I sent it over to Kim at the hospital. I went in last Thursday and met with Kim and Daryl for a few hours. We talked about design specifics and came up with something that they're actually using right now. I dropped 200 of them off at Keck on Tuesday, and we expect to drop another 200 off today. So you are currently seeing a finished face shield. It is extremely simple. It is a clear plastic shield with a non-latex elastic band stapled onto it. And then there is a polyurethane foam forehead rest. We've actually moved to using 2 staples on each side just as a backup. Next slide, please. So these are very quick to produce on a laser cutter. You could also cut the plastic sheet with a CNC mill, possibly a vinyl cutter, depending on the thickness of the plastic you're using. And if you have access to die cutting capabilities, you could really mass produce these. I know a lot of plastic suppliers also have very large format lasers themselves, so you could purchase pre-cut shields and assemble them if you don't have those capabilities. We are using a sharp utility knife to cut the foam. Some people have said they thought they needed a hot knife, but it cuts very well with just a snap-off utility knife, and we're using a standard stapler. As far as materials, it seems like any clear plastic between 0.008 inches and 0.02 inches works for these disposable models. There are plastics you would not want to use for something that you're going to wipe down and reuse. We have been using PETG, which could be reused. As some people have alluded to, sourcing some of these materials is getting trickier or less consistent. So we're going to try to continue to use the PETG, and we're actually going to move to the standardized shield design that Daryl was talking about earlier, so that there is the potential of removing the shield from these disposable models, storing it, and cleaning it and putting it onto the 3D printed headbands. For the elastic, we have been using hospital standard, oh, I have a typo, latex-free tourniquets. They're available in bulk, and if somebody needs to switch one out in the hospital, they have them on hand. We are using a soft polyurethane foam that's 1.5 inches thick and backed with adhesive. That's based off of a commercially produced design that I got from Kim. And then we're using regular stainless steel staples. Next slide, please. The design is a 9.5 inch tall, 13 inch wide shield. It's user modifiable, so if somebody needs to make this tighter, they can take a regular stapler and add another staple to the strap to bring it in. If they need to make the strap longer, they can remove the one that's on there and add a new hospital tourniquet. These are very easy to assemble. I personally put 200 together on Tuesday in about 5 hours. I recommend distributing the work if you can. My hands were pretty tired after that. We have spent about $2.50 per shield to make 480 shields. as the costs change depending on your source. So that's a good idea of how much these cost, but it does vary. We're getting our foam from McMaster Carr, and we're getting it in 24 by 24 inch by 1.5 inch blocks. If you go with like a polyurethane upholstery foam, you can get that more easily and more cheaply, but you'd have to add adhesive. The commercially produced ones are glued onto the shield. I have not explored different adhesive options for that. We got our PETG from Solter Plastics, which is in Los Angeles. I know they're sold out for at least the next week. And the straps originally came from Keck Hospital, but are widely available. Next slide, please. So I have the dubious honor of having had jobs where I've done a single task repeatably and consistently. I'm an artist, so I've often done a lot of things in sort of a homemade assembly line format. So I wanted to give some workflow tips because the design is simple, assembly is simple. Pardon me. It's really, it makes a difference if you set up your workspace. So wherever possible, use laser cut guides instead of measuring. Arrange your workspace with dedicated work areas for each task so you're not moving things around too much. Do your prep work for a large batch before assembling. So don't take one shield and assemble it completely. It's more efficient to do things in groups. Perform each step in batches. Think about how to create an assembly line for multiple people while maintaining social distancing. In our fairly large lab, we have a maximum of 3 people at a given time. And we wouldn't want more than that. But even with just 3 people in 5,000 square feet, we want to be careful with how we lay out our production. When you're assembling these, the foam should be offset from the top of the shield by about 1/8 of an inch to keep the user's hair from coming in contact with the exposed adhesive. And I have a jig that I've designed to help do that consistently. If your clear plastic comes with a protective film, especially if it's the thicker material, leave it on while you're using the laser if you can, and then remove it before assembly. So that removes the step of having to clean combustion products off of the film. And it also, if you leave it on one side, a lot of users will think that the plastic is just cloudy. They won't know that there's a film on there that they should be removing. Next slide, please. So here's an illustration of my work table and the workflow. I have my pre-cut adhesive backed foam set next to the stacked and peeled laser cut shields. This light blue L-shaped object is an assembly guide that I've made that has an offset to help with foam placement. So I work through about 60 of these, just putting the foam on the shield, set them over to the right in stacks of 8. Once I've got 60, I move over to where I have my stapler and my bag of pre-cut straps. And quickly, I'm just putting 2 staples on either side and then making stacks of 8 to the right of that by our 16 by 20 inch Ziploc bags. Once I have 8 in a bag, I stack those bags, and before they get taken to Keck Hospital, every single bag is labeled with the number of items, our name, the date they were bagged, and then the materials. Next slide, please. So just some images from my production. On the left, you'll see I have this laser cut ruler. It's 1 1/8 inch wide and 26 inches tall. If you're doing the same thing over and over again, instead of measuring each time, try to make some object that is the size you want the final product to be, so that you don't have to do any thinking, any measuring. On the right, I've highlighted my clear L-shaped template. This is what I use to help with assembly. It also is the ruler that I use to cut down the elastic straps. Next slide. So here's the assembly of the foam and an illustration of how that jig maintains the offset. The jig is made out of two pieces, the L and then a block that's just adhered on top of that, pushed up 1/8 of an inch. I find that really helpful. Next slide. So completing everything in batches, doing stacks of 8. It works out very neatly. Our laser can cut 8 shields out of a single sheet. 8 of these shields, or finished shields, fit in one of our bags, so I keep things in that number. This also helps with counting, just cutting as many steps out of the process as possible. Next slide. That's it. Each bag is labeled individually so that Kim knows where they came from, when they were bagged, what material they are. I want to be very clear on the labeling that it is non-latex elastic, and we're trying to deliver these to the hospital in sets of 200 so that they can train to them and have a nice deployable set. That's all for my presentation. I'm happy to answer any questions.
All right, thank you so much, Tucker. We have our first question coming from Grant Delgatti about standard foam kitchen scrubbers.
Oh yeah, but I think Jacob answered it below.
Okay.
So Jacob, you said that it needs to be 1.5 inches thick.
Yeah, that helps the proper shield offset. And then it also has a certain length to kind of wrap around the forehead and provide that that shield from any moisture getting in.
Got it. Okay.
Yeah, it has to sit away from the face. Oh, sorry.
Tiffany, let's just take one more question and then let's move on to Daniel, basically.
Okay.
Yeah,
Great.
Tucker, you were saying something?
I was just adding that the shield itself has to sit far enough away from the face so that people with glasses can use it. It's not hitting their nose or contacting the mask.
I just want to weigh in on that really quickly. We did a lot of testing with infection prevention about the positioning of the mask. And two of the concerns that a lot of these models that have been put out that don't address is the fact that it needs to be offset for the head by that much. If you're going to be wearing a mask, it will fog up completely if it's touching that close. So the space is very important. And also the accommodation of people with and without glasses, that 1.5 inches is very vital. And if you take a look, there's a lot of models out there for the 3D printed version that doesn't have that spacing and becomes not only not usable, but very, very uncomfortable for people to try to adapt and wear. And that's been one of the model design concerns that we've been trying to work with infection prevention and the people that are actually going to be using these shields.